Hello everyone, how's everybody doing? Hope you're doing fine. We got another little lecture, little class today. I'll be dealing with a fellow we left behind, about a week ago, Mr. St. Thomas Aquinas. And I'm going to re-baptize him. I'm going to call him St. Thomas Aquanum. He was the inventor of quantum, as we will see today. Before I get to that, I'm going to be answering some questions, some comments that some people have made. And even before that, I want to make sure people understand that we're going to Lusaka, Zambia. We're going to have our 8th Rational Physics Conference over there. We've already did what? Europe, North America, we went to Mexico, South America, we're in Argentina. Here in Europe, we had a couple in England and here in Germany. And we haven't had any in the East, so we just need to get someone over there to host it. But right now we're going to be doing it in Lusaka, fighting with hyenas and lions, who knows what. Okay, so just be aware, 4th of April, that's a Saturday. See if you can get there. Several flights going from Europe to Africa, typically through Addis Ababa or, well, some other countries and cities. Anyways, let's get on with the questions today. We've got a first comment that's got to do with extinction, and I'm just going to deal with one comment on extinction today, okay? And what's the issue? The issue is that, I have a theory, and it goes that humans are about to become extinct. We're the last generation of humans. And one of the questions pops up is, what do you mean by a generation? Are you saying me? Are you saying my grandson? I mean, you may be born in the same century. Like, take as an example, Galileo. He died when Newton was born. And the question is, were they of the same generation when they never got to know each other, like personally, And yeah, generation is a very broad term, very undefined term. It just gives you an idea that it's all the people around the same period of time. That's about it. And so there's no scientific way of putting it in those terms, in precise terms. When I say that we're the last generation, I'm saying it's imminent. It's going to happen maybe after I die. Maybe it's going to happen before I die. It can happen any time. That's the notion that I have. Now, this person asked, let us assume extinction is going to happen 40 years from now. Okay, what does it matter to me? By that time, I probably is dead. Okay, and long gone. It is the next generation who will suffer. On the other hand, if it is going to happen in 10 years, in all probabilities, I will be there. Isn't it better to know that one is going to die naturally than knowing that I'm going to be killed and eaten by my fellow humans who are my friends and relatives? Isn't a time frame an essential part? Yeah, obviously people want to know if extinction is imminent. People want to know if they're part of that imminence. Okay, is it going to happen after I die? I don't care, right? Well, maybe you do care if you have kids. I have 3 boys, and big boys now. And you would think that, or you would like for them to do their normal lives, to old age and so on. And I don't think it's going to happen for them. And so for me, it's a concern because, I love my kids. And so knowing or having this feeling that you're the last generation, that your kids are not going to see retirement age, well, I don't know if it affects everybody in the same way. Of course, if you don't have kids, it may not affect you. It does affect me. Okay, so yeah, knowing whether it's going to happen sooner or later is important, but well, I'll answer that in a second here. It says, irrespective of what everyone says, people are more interested in knowing what happens to oneself. Okay, as you rightly said, people always think extinction happens to another generation, not one's own. Yeah, that's true. Every bit. All the movies, they're all in the future. They all happen in the year 3000. Okay, and even in fact, they never end in extinction. They always have a baby at the end, and that's, you know, the thing starts all over again. How long will I live and how will I die isn't what everyone is asking. It isn't what everyone's asking. All the comments denying the theory, aren't they telling their hope that they are not going to be part of the extinction you are predicting for this generation? And so here's my reply to that. Put it on side by side. Well, I'm not an astrologer. You know, I cannot tell you when it's going to happen. I can't tell it's going to happen on the 1st of May of the year 2030. You know, I can't tell you that. And not even God can tell you that. And the fact that I cannot predict the exact day of extinction does not invalidate the theory, the mechanism of extinction. You know, sometimes we don't deal with predictions like they do in mathematical physics. In science, we deal with explanation. We have to explain a mechanism. And the mechanism of mass extinction has to do with the disappearance of a food chain, and not with what you read about, you know, out there in the literature or in blogs and whatever, saying that it was due to catastrophic accidents, you know, acts of God. And he who doesn't like the food theory has to explain, you know, past extinctions. That's the starting point. Past mass extinctions occurred because of food. The ecological pyramid overturned. That's the theory. So, you know, I'm saying that we're going to die, humans are going to die in a mass extinction. It's going to happen soon, and it's going to happen because of food. We already have the reason, the cause, and the mechanism. And if you don't like that, we'll start by telling me how animals in the past died. And hopefully you can explain the only thing that extinction theory has to explain, which is selectivity. Okay. The only other thing I want to say there is that, you know, in general, my idea why it's going to be so imminent and why the global economy is going to crash. One of the features I look at, or one of the things I look at, is China. China is the motor of the planet. It's been so for maybe the last 20, 25 years. China was way backward, you know, and started growing, and became an economic powerhouse. You have to remember, in the 60s, China did not exist. Essentially, it was such a poor country, and it was so underdeveloped that for all practical purposes, there was no such thing as China. It was not part of the global market in any significant way. And when Nixon went to see Deng Xiaoping over there in, in 75 or thereabouts, that's when the United States started selling things, and the Europeans started selling things to China. China became a manufacturing powerhouse, stole all the manufacturing from the West. The West, you know, around the 80s, time of Reagan, began to grow as a service economy, and Europe as well, and Japan as well. They went from manufacturing to services, and China remained with all the manufacturing, okay, because it was cheaper to manufacture stuff there, even by, you know, multinationals. And now, you know, if you look at the chart, see if I get it here. Here you see the chart. You can see that China now, about a few years ago, services has surpassed manufacturing. And services is going to take over China. China's going to become a service economy. And as it does, it's not going to grow as much as it's been growing lately. And here you can see another little graph. See if I can get it up here. Put it over here. Last 3 years, I saw an article recently. Last 3 years, the sales of cars in China has gone down, and this year it's predicted to go even further down. I think they're going to lose like 2% of sales. In other words, what has happened, the Chinese economy is becoming saturated. It can't continue growing at 25% like it was like 20, 25 years ago. Today it's growing at 5% only, and tomorrow it's going to be growing at 4, 3, 2, 1. When China, not if, but when China starts growing at a slower rate, it's going to be a bottleneck for United States, for Europe, and for Japan, and other countries that sell to China and buy from China. So the global economy is going to start growing slower and slower and slower until it grows no more. There's going to be zero economic growth on the planet. And people have this idea, we've always grown. Yeah, we've always grown, and we are in a new age now. Our age today is that we don't grow anymore. First, we don't grow exponentially anymore, like in the 19th century. And now it's becoming concave. It's the curve is flattening out. At some point, we reach zero growth. And when that happens, not if, but when it happens, the whole global economy is going to be in trouble. Okay, companies are going to shut down. They're going to kick people out into the streets. Unemployment's going to grow. Okay, and nothing is going to overrule no amount of money creation or debt, incurring debt by governments is going to change that. Okay, we're going to reach a point of maximum growth for the planet. When that happens, we're all in trouble. Okay, because a lot of things are going to happen at that point in time. Companies are going to suffer. There's going to be more and more mergers than what we see today. In fact, lots of people in the streets, more unemployed, looking for internet jobs, services, some kind of thing that you do. And, and there's not room enough for everybody. And you might think there is, but no. So all I can tell you is I look at these things like these numbers here that give me an idea that something is wrong with the global economy. Anyways, I think I think the global economy is going to collapse. When it does, then at that point, nobody produces food. There's no reason to produce food and ship it to the cities because money is no more. Okay, that's the theory in a nutshell. Anyways, let's go with the next one. This has to do more with what we discussed in the last couple times, which is about the existence of God. And this is not a philosophical issue. Some people say, well, that's philosophy. No. The word exist belongs exclusively to physics. Physics studies and tries to explain that which exists and what happened. Okay, so if someone claims that God exists or God doesn't exist or maybe he exists, that issue belongs to physics, falls squarely within physics. And that involves location, involves motion, all things related to physics, not to philosophy. So this thing that was created in the past by Aristotle, metaphysics, ontology, plays no part. That stuff stays in philosophy. Whatever they do there, we don't care. Existence belongs to physics. You say that a table exists, you're talking about physics. You cross the line into physics. Now we're talking physics. And so that's the issue. That's the context for God, for the existence of God. One fellow who apparently likes God a lot. God is not a physical object. Oh, okay. Thanks for telling me. Because the Bible says, the Bible says that God was a burning bush. And the Bible says that God, his spirit floated over the face of the waters. And he, uses the word he, right, created us in his image. So I don't know how he cannot be a physical object if an object is that which has shape, and God seems to meet that specification. Okay, God is not an abstraction. Okay, so he's not an object, he's not an abstraction. What is he then? There's only two possibilities, okay, but he is a being concrete, whatever that means. However, not in the ordinary sense of that term concrete. Oh, okay, so he's not like the concrete we put on the floor, okay? Cement or whatever. You will have to forgive the narrowness of human language here. Yeah, I can see that, especially narrowness of your explanation. God is that active force. If God is a force, God is an abstraction, God is a concept. Okay, so how do we answer these things? Well, here's my version side by side, okay, so you can see it. Okay, and God is a word A word has only two possibilities in rationality: object or concept. You cannot be both. You cannot be an object and be a concept, okay? An object is that which has shape. Concept is a word that invokes or embodies two objects, or two words momentarily treated as objects. God cannot be both or neither. God is either an object or a concept. There is no third category of words for the purposes of science. It is up to the naysayer to propose a third category and defend his proposal. So, I mean, we need to be able to follow his dissertation. When he says God exists, or God is this, or God is not that, we need to follow what he's saying. So far, this person cannot make sense of his words, because he says God is not an object, God is not a concept. That's what he's saying there. So what is God? We need to know what God is. The proponent of God has to choose whether his notion of the word God is one or the other, object or concept. Saying that God is neither an object or an abstraction is an attempt to elude punishment in rationality. And again, force is a concept, okay? So, yeah, I don't know. You got to tell me what you think God is. And you can't say, well, if I knew, God wouldn't be so great, which is one answer that I received. It's a way of eluding the question. That's all it is. You have no answer, and that's why you're saying, well, God is not that and God is not the other, and whatever you say, God is not. Okay, tell me what God is. Okay, that's what you got to tell me. I need to be able to follow your reasoning, okay, if you have any. Okay, here's another comment. I think St. Paul, God is a real spiritual being, whatever that is, right? He's a ghost, he's a magician, he's energy. What is God, that exists in time and space? Both immanent and transcendent, not virtually present only, but substantially present, okay? It cannot be that he is nowhere. So he told me God is not an object, God is not a concept, he's not an abstraction. I don't know what God is, but cannot be that God is nowhere. The notion that God exists only outside of space and time is false. God exists in time and space. Okay, so how do we answer this? Let's get to it. Here you have my side by side. Only objects can be said to exist. Exist means physical presence. The physical part invokes an object, and the presence part invokes location. If God is not an object, God does not exist pursuant to the definition of the word exist. Okay? So God has to be an object to begin with, because that's the definition. You don't like the definition? Good. The naysayer has to define exist in order for the crowd to follow his reasoning. If God is somewhere, then God is an object. God cannot be somewhere and not be an object, because what is in that space, in that place, in whatever, in that location? God has location, distance to every atom in the universe. Naysayer has to provide alternative definitions for these key words, okay? And so, yeah, you need to define your terms so we can follow your presentation. And the important thing you should know is no one in the last 10,000 years has been able to define the word exist. That's why atheists and theists run around in circles, because no one has defined the word exist, neither atheists nor theists. And the only issue there is, if you don't like my definition, you define exist, so we know what you're talking about. That's the important word in the phrase or sentence or whatever. God exists. When someone says God exists, God is important. You got to tell me whether God is an object or a concept. But the important word is the word exist. You got to know what the word exist means, and not a single atheist or theist knows what the word exist means, or agnostic for that matter. Okay. Another comment. Okay, moving on here. Says, if you think you will be able to explain all things through human language, you are deluding yourself. You cannot even explain to me how it is that you move your hand. Okay, this is how I move my hand. You will never be able to do so in purely mechanistic language. When you explain something mechanically, you are never really explaining it. Oh, okay, so what am I doing now? You are merely explaining one layer of many more upon within that thing. Okay? In order to be able to answer him, we need to define what we mean by an explanation, essentially. And science is about rational explanation. What is an explanation or to explain? We define it, and that way we know what we're saying when we use the word explain. Making a movie so that the viewers understand the mechanism proposed. That's for the purposes of physics. Okay. Otherwise, he's got to define explain or explanation. The language of physics is not mathematics. The language of physics is illustration. I should be able to illustrate a mechanism, okay? If you cannot illustrate your theory, you are not doing physics. In science, we explain one mechanism at a time. He who cannot explain a mechanism but insists that God somehow created the universe is delusional. He's sharing his ignorance with the crowd. I mean, you got to tell me how God created if you say that God created the universe, tell me the mechanism. Don't tell me he did. Just tell me what the mechanism is. Then we can follow, then we can see what you have in your head, in your brain. See, for example, here's an incident, and I'm going to explain it in the way we do it in physics, which is with a movie. If I put in a movie and you watch the movie and you can tell how something happened, you have explained it because you are able to make a movie. And all you need to explain is one incident at a time. You don't have to explain iteration after iteration after iteration, right? Endless explanations of explanations of explanations. That's not science. Science is explain one thing at a time. Okay, and here we have a good old. Let's see if I can get this bigger. Here we have good old Felix the cat, and I want you to tell me if you can figure out by watching this if you know how he broke the window. Tell me how the window broke. That's all I want to know. Did you figure it out? Do you need more time? Maybe, to figure it out. This is simple. Make a movie of a mechanism, and we can tell you, and you will be able to explain that mechanism. Someone asks you, how did the window break? Yeah, I can explain it. The window broke because a magnet or a horseshoe went through the window. Very easy. What part did you not understand of my explanation? So, this notion that he has that, you cannot explain anything, it's nonsense. Obviously, he doesn't know what he's talking about. And I don't know if it was the same fellow, but here it says, I don't believe God exists. I know with absolute certainty that God is that he is. And my answer is belief, to believe, knowledge, to know. Okay, they're equal. Knowledge and belief are synonyms. Knowledge is defined still with Plato's definition, which is justified true belief. So knowledge is belief. Anyone who says he knows, he's just telling you what his belief is. Okay, and what is belief? It's just personal opinion. What is opinion? Religion. So we don't care about that, at least here. Here we only care about what you can explain, not what you believe. Okay. And so belief has nothing to do with science. Now he says God endures forever, okay, whatever forever is, even through time, and is everywhere present in space, even in space. So he's everywhere. And before he said he was outside of time and space or within time and space. Now he's everywhere in time and or at least in space, right? Well, if God is everywhere present, then the word God has no meaning. If God is everything, God is nothing. Okay, and so to say that God is everything, God is everywhere, and God is throughout time, you're not saying anything. All you're saying is just babbling about something you cannot explain in any rational term. Okay, and so God is a synonym of nothing in this context. If God is everything, God is nothing as well. God is vacuum, space, empty space. So if God is everything, you want to at least eliminate space, vacuum, because otherwise we say, hey, God is also nothing. He's something and nothing at the same time. This kind of thing. Okay, here we have another comment. This is from another fellow, and he wants to introduce God through quantum mechanics. Okay, he wants to show that just like in quantum mechanics, which has been proven, right? God is everywhere, right? And so he says, God is all pervading. God is everywhere means God is present at each and every point of the universe, equally present everywhere. One cannot be distant from one's own self. That's why God is everywhere, because he is himself, and God is everything, and everything is itself. Okay? that distance from any point of space to each and every other point of space is really zero. Okay, we have zero distance between 2 points. Why? Because they're one and the same. That's essentially what he's saying, which is irrational. Either we have 2 or we have 1. And he says we have 2 points in space, but they're at the same place because the object that contains those 2 points is one, in this case, God. But I like the next one. He says, has already been confirmed by science through the phenomenon of quantum entanglement. Well, the first thing we have to realize is that quantum entanglement has not been proven. Quantum entanglement is a word that is applied to an unknown, something the mathematicians have no clue how to explain in rational terms. So they call it entanglement. They say this particle over here affects that one over there. That's called entanglement. How it does it, the jury is still out. They have no idea how to explain that. And in fact, this fellow references an article. And here's the article very quickly, right? This article comes from Quantum Magazine. So I guess you know what they're going to talk about. They're going to vouch for the irrationality of quantum mechanics. It says, quantum entanglement, a phenomenon in which particles or points in a field, such as the electromagnetic field, shed their separate identities and assume a shared existence with one another's. In other words, they become one. God, everywhere, he's only one. He's himself. I am what I am. Okay? And so he says, normally physicists think of these correlations as spanning space, linking far-flung locations. But a growing body of research is investigating how these correlations can span time as well. What happens now can be correlated with what happens later in ways that elude a simple mechanistic explanation. And there's the key. They cannot explain this. I mean, you know, to say that this is what particles do, that they affect each other through time and through space and through whatever. What these people are doing is eluding the main issue. The main issue is, please explain the mechanism. What is the physical mechanism? That's what a physicist does. You know, a mathematician, you can, you know, he just says it does so. We measured. This is what we observed. How can you observe if it's invisible? Well, this is what we detected. You know, something affected something at a distance, and that's what we'll call entanglement. So they don't have an explanation. So to use the word entanglement, you know, to show that, oh, I know a lot about quantum mechanics and science because I can say the word entanglement. No, you have to explain entanglement, and not a single so-called mathematical physicist can explain it to this day. Okay. So here's a little picture that they had in that article of entanglement. How, you know, they show that you're painting the head of one bust there, and it shows up on the picture later. You know, again, is this science, or what are we going to call that? I mean, if you think that's science, because the so-called scientists proved it all over the world and you just bought into it, well, all you are is just drinking Kool-Aid. You know, you haven't explained it. Explain to me how that happens. I mean, in Hollywood, we can do a lot of stuff like that was done, you know. But show me in a lab. Let's go to a lab and show me how you do that same thing. And, of course, you won't be able to do that, okay, because it's nonsense. The physical interpretations of quantum mechanics are nonsense. Okay, moving on here. One fella asks or says, what do you say to people who regard mathematical objects as mere instruments? Well, you know, we don't have these things in physics, mathematical objects, whatever they are. And here's my answer. Side by side, the mathematics has nothing to do with science. Science, rational explanations, not measurement, not numbers, not equations. That has nothing to do with science. That has to do with calculating, with describing, because that's all that mathematical physics does. It describes, and then it gives you an irrational explanation for what it just described. And, and that's what an equation is, just a description. If you look at any equation, it doesn't explain anything. I mean, the fact that I can tell you how fast or what the acceleration of gravity is doesn't tell me what causes gravity, which is what we're trying to find out. We want a qualitative answer to that question, not a quantitative one. And so what these people do is, you can say, is unscientific. Unscientific in the sense that science is not about doing equations, it's not about doing measurements. Science is about explaining, as it relates to physics, is about explaining a mechanism. If you haven't explained a mechanism, you are not a physicist. Just that simple. And yeah, a lot of people don't like that because that's what they've been taught for, by rote in college and in school. And they've been taught that, science is about measurement, about numbers, about equations. And that's the notion that's trickle true. Why? Because the mathematicians run the planet, the scientific world. And so this is the problem. The problem is just people absorb that and never question that. What do you mean? You measured the table and you did science. You got an equation for how fast the clock goes around. The big hand and small hand. So you got an equation. That's science. Just putting an equation. And then they also confuse technology. GPS, they say, oh, GPS proved general relativity. And, what is it? Time dilation proves special relativity. For quantum mechanics, they say, what's a good one for quantum mechanics? They say that they've proven that a particle can be at two places at once. And again, it's just an interpretation of what they did not observe because they did not see it with their eyes. But see, they talk about proof, about having proven all these things. And that technology somehow corroborates that. Like they use the word quantum computer. Does a quantum computer prove quantum theory? No, quantum computer, the word quantum means ignorance. That's what the word quantum means, okay? Every time you see the word quantum, it means ignorance. So when you have a quantum computer, you have an ignorance computer. It means that the guy has no idea how it works at the subatomic level. All he knows is that it does work because he developed the machine through trial and error. He says, oh, look, we have a magnet here. It attracts another one there. We can use that for something. He doesn't know how the magnet attracted the other one. And he doesn't even care. I mean, because he said, well, I can't explain it. But he can use the technology. So the technology does not confirm that he's got a theory for how a magnet attracts another. And the same with GPS. GPS does not confirm relativity, okay? Because what that would mean is that GPS confirms that space is warped and that time dilation occurs and all this other nonsense created by mathematical physics. And the only thing there is you have to explain it rationally. You have to explain it with mechanisms and not just tell me that time dilates, that time stretches. What do you mean? Time stretch. What do you mean a twin can be older than his brother or much younger, whatever? So this is what you got to explain. And when they give an irrational interpretation, they cannot say GPS confirms it. No, it doesn't confirm the theory, the physical interpretation. Okay, it might confirm the equations, which is the measurement. That's different. It doesn't confirm the theory of the explanation given for that phenomenon. That's the issue. Okay, and then the last comment here concerning energy, a word that I detest to... My son asked me about that. I said, I detest the word energy, okay? I'm trying to find a useful definition for energy. Energy, the ability to cause effects. Used in a sentence, that baseball had a lot of energy, okay? And what's my argument there? I'm saying the word energy masks more than what it reveals. It just hides stuff from our face, from our eyes. Okay, we use the word energy, and I've got a Quora article that says energy means spirit. In the old days, they used to call it spirit. Now we call it energy. That's the only difference. The word means exactly the same as spirit in the old days. A concept such as the ability has no muscle to cause effects on objects. So if energy is the ability, blah, 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 I don't care. The ability has no... I can't transfer the ability to you. Here, catch my ability. Okay, I can't move things with ability. Okay, ability is a concept. If energy is a concept, you can't use it as a physical object. You can't use it as a brick to break the window like Felix did. And again, it says the baseball bat had a lot of energy. Does a baseball bat possess energy like it possesses a chunk of leather around it? You know, it's like I explained to someone, when you say, I have a headache, is that the same thing as saying I have 10 cents in my pocket? A dime in my pocket? So the word have is worrisome because the word have is used in ordinary speech to relate to objects and concepts. And we don't have a word that separates them in, you know, that perfectly well, okay? And that's part of the problem. The word have, that verb is a problem also. People are not so always aware of that. And so like the words mass, time, force, charge, wave, and field, the word energy has no place in science. The word energy means spirit. Okay? Every time you use the word energy, you're saying spirit. That's what you pay for every month to the utility company, for spirits. Okay? And we cannot explain a single mechanism with these mathematical concepts because concepts cannot be placed on the screen to simulate a phenomenon, a mechanism. I cannot put energy on the screen for you to understand what I'm talking about, okay? See, if you could see energy on the screen, you say, okay, I see energy there, I see how you transferred it. I see how it expanded, I see how it got shrunk or whatever. You do something with it, but you can't put energy on the screen. What are you going to put? A little cloud of whatever? A spirit? You're going to put a little ghost there? What is energy? No one knows because no one has ever defined it, okay? And there are many different definitions, in fact, of energy, and one has nothing to do with the other, but none of them represent a physical object. You cannot draw a picture of energy. Okay, whatever you draw is not what the other guy's going to draw. We don't have a single meaning for the word energy. Okay, let's move on to Mr. St. Thomas Aquinas, which I rebaptized as St. Thomas Aquanum. Okay, Aquanum. Why? Because the other day I put this up here and said that Thomas invented quantum mechanics. This is in the 13th century. Okay, he asked these questions. Okay, and this is how he phrased them. He says whether a particle is altogether incorporeal, whether a particle is composed of matter and form, whether the particles exist in any great number, whether the particles differ in species, whether there are different types of particles, right? Whether a particle is in a place, whether it has location, okay? Whether a particle can be at several places at once, whether several particles can be at the same time in the same place, okay? And whether a particle passes through the intermediate space, okay? And whether the movement of a particle is instantaneous. These were the questions that St. Thomas Aquanum, asked about 1,000 years ago. It turns out that he was really referring to this, okay? He didn't use the word particle, he used the word angel, okay? And so, that's just wording, I guess. If today we call them particles and he called them angels, okay, I don't see why he should not be given a retroactive Nobel Prize for having discovered quantum mechanics. I think he earned it, right? And you can see this when we put how quantum deals with particles today. And here you have side by side, what quantum does. They ask these same questions, or they dealt with the same subject matter. Whether a particle is altogether incorporeal, whether it's composed of matter and form, etc., etc., etc. And so we go down the line, we find out that, we have the same issues today, except that we're not using Aquinas's angels. What we're calling them is particles, but we're also giving them these magic properties. And let's see how they match up. I'll go one by one here. Okay, here's the first one. And whether a particle is altogether incorporeal. What do you see in the literature? In quantum mechanics, a particle is a concept. It's either an excited field, charge, wavicle, which is a wave packet, or a small localized object, which is, if you look up the word object, it's a collection of matter. A collection of matter is not a physical object. Collection of matter is known as a concept. Okay, a collection of trees is a forest. Okay, a collection of people is people, and a collection of little kids is known as children, and so on. You know, collection is a concept. A physical object is what you can point to and draw on the board, and you know, it's not made of parts. Okay, that's called mereology. Anyways, if you can look at these, Sean Carroll, a famous quantum mathematician in the tradition of St. Thomas Aquinas, says every particle is actually a field. The universe is full of fields, and what we think of as particles are just excitations of those fields. Like waves in an ocean, an electron, for example, is just an excitation of an electron field. So what is a field? Well, a field is a concept. That's what it is. Field is just a bunch of numbers around an object. It's strength or weakness could be a magnetic field, it could be an electric field, could be a gravitational field. It just says that as you get further and further away from the main object, the so-called field, the numbers decrease, the strength of whatever's there decreases. That's all a field is in physical terms. And so to say that a particle is just a vibrating field, he hasn't said anything. Electric charge is carried by subatomic particles. Okay, so here we have a concept that is carried by particles. Charge is quantized. So here we have a discrete packet of charge, whatever this is. The smallest charge which can exist freely. Exists freely? That means it's a standalone object, right? So please draw a charge for me. I need to see a picture of what a charge looks like. If the charge is moving, it also generates a magnetic field. So that if the charge moves, that means it's a physical object. Again, we're treating this concept as a physical object. So is the charge incorporeal or not? Is an excited field incorporeal or not? And then we have the famous wavicle, the wave packet. Particle duality is the concept. So it's a concept, not an object. So is it corporeal or incorporeal? In quantum mechanics, that every particle or quantum entity may be described as either particle or a wave. Well, if it's described as a particle, we can accept it, okay? You can say, for example, you know, that you can draw the particle and say, look, that's a particle. And we can see it, and we know what you're talking about. Please draw a field. What are you going to draw? Football field? Poppy field? What are you going to draw? Charge? What are you going to draw? But these words are concepts, they're mathematical concepts. They have values attached to them. Charge is what? 1.6 times 10 to the minus 19 coulombs. That's a measure of something, right? We're not talking about a physical standalone object. We're talking about a number, and that represents charge. But these people talk about the charge moving. So are particles incorporeal, or are they... you know, here it is again, or are they concepts? This is what we need to figure out. Okay, so there is no difference in the way St. Thomas used angels and quantum mechanics uses so-called particles, okay, with which they claim to interpret the physical world around us. Okay, here's, no, wrong one. Let's get it here. Got so many of these, sometimes hard to get them up there. Okay, yeah, let's go with the second issue there. It says whether a particle is composed of matter and form. Let's see what quantum says. The survey says point particle. What is a point particle? An idealization of particles heavily used in physics. Heavily used, okay, in physics? I don't know. Its defining feature is that it lacks spatial extension. Okay, being zero-dimensional, it does not take up space. So what is it made out of? What kind of matter, what kind of form does it have? Looks like none. Okay, that's what quantum answers. How about mass? A point mass, meaning a point particle with a non-zero mass and no other properties or structure. So what are quantum particles made of? Well, I guess they're not made of much. They're made of all this concepts, mathematical they're quantities. That's what they are. They're mathematical concepts, quantities. No difference between the angel and the particles of quantum so far. Okay, the descriptions that St. Thomas Aquinas gave gave the angels applies just as well to every particle of quantum mechanics. The concepts, the notions, have not changed in 1,000 years, or they've been resuscitated, you could say, okay, by people like Bohr and Rutherford. Okay, let's look at the next one. Okay, it says whether the particles exist in great numbers. Well, if you look up the Dirac sea, a theoretical model of the vacuum as an infinite sea of particles. Sounds familiar? QED vacuum is a state with no matter particles and no photons. QED vacuum contains vacuum fluctuations, virtual particles that pop into and out of existence, and a finite energy called vacuum energy. So it's got no particles, no photons, whatever those are, but it does have virtual particles that come in through the magic wand of God, I guess, you know, and whatever vacuum energy is. And what did we decide energy was? Absolutely nothing. It's a concept. So the vacuum, this vacuum, QED vacuum, is made of virtual particles, magical particles, and a concept called vacuum energy. So we got lots of that. I guess that's infinite, right? You can create as many miraculous or magical particles as you want. And it says in QCD, multiple vacuum states exist. Okay, so is it infinite? Yeah, I guess the quantum mathematician would say it's infinite. They like the word infinite because it eliminates all questions. See, if they said it's finite, people say, well, what's outside of it? And so they say, no, it's infinite. And infinite can mean structural or counting, you know, and they usually refer to counting. They say you can count forever and you'll never count the last one, so to speak. And that's called infinite. It's not infinite, really. We call it incessant in science, not infinite, okay? Let's go with the next one. And here it is. Whether particles differ in species. Well, you have the standard model of quantum mechanics, and yeah, it's all these particles supposedly are different. But see, the problem here is that quantum mechanics predicts, to use their term, predicts that there should be a single particle at the end of the yellow brick road. You can't continue chopping a particle in half and arrive at nothing, as Democritus and Leucippus said, you know, over 2,000 years ago. You can't continue chopping something and end up with absolutely nothing. At some point, you got to end up with something. And so the assumptions of quantum mechanics already include the fact that there is one particle that underlies it all. And so you know, you can't escape that in quantum mechanics. So be aware that quantum mechanics does predict a single particle at the end of the yellow brick road, okay? And whether a particle is in a place, okay? And yeah, it says the electron is everywhere. Okay, so I guess it's like God. All particles are actually excited fields. Okay, what is a field? A region or space in which a given effect, such as magnetism, exists. That's one definition in one dictionary. Another dictionary says the influence of some agent, as electricity or gravitation, considered as existing at all points in space. And it says fields extend to infinity. Okay. So what's the answer to whether a particle is in a place? Well, it's like God. We had that a minute ago. The particle is everywhere. And that solves all questions. You know, the reporters have no more questions after that because the particle is everywhere. So, okay, so that answered your question, okay? Okay, here's another one. This is from Mr. Victor Toth. He's a guy who writes in Quora. A bunch of nonsense that he writes on behalf of the establishment. He says the standard model of particle physics, of quantum field physics, its fundamental objects are all fields. Okay, so we have fields, which are concepts. That's the bread and butter. That's the building block. This theory has two fundamental objects, the electromagnetic field and the electron field. So we have fields and fields and fields. We have poppy fields, corn fields, wheat fields, you know. And that's it. These fields are functions of space-time coordinates. What does coordinate have to do with a standalone object? I have no idea. These fields are present everywhere. Sounds familiar? It's like God, right? They're everywhere. These fields are quantum fields, okay? When they interact, that means now we're talking about fields interacting. That means they're talking about an object. Quickly, he switched over to physical object. He started as a concept, and now he moves into object. He says they interact. They exchange energy, okay? So they exchange this ghost, this thing they call energy, whatever energy is. Please draw it on the board so I know what they exchanged, okay? And momentum, another concept. These units of excitation have a distinct existence. How can excitation have existence? What has existence, if you define the word exist, is an object that has location. That's what has existence. You cannot say the excitation or the fields or the momentum or the energy exists, because those are concepts. Concepts do not exist in physics. Okay? And these unit excitations are particles. That's what they call particles. These excitations of fields of whatever you got in there. These units of excitations do not necessarily have a specific location. No kidding. How can they if they're concepts? They are not miniature cannonballs, okay? So there he's accepting that, we're not talking about particles, corpuscles, what everybody understands by the word particle. They're saying that this is a concept. It's a vibrating field, and a field is a concept, so what you have is a vibrating number, a bunch of units, that's what's vibrating. The excitations of the electromagnetic field or the electron field are not spatially localized. Of course they cannot be. They're indeed everywhere. See, this is how they get you off their back. It's everywhere. You understood? Okay? The natural state of these excitations is that they are spread out in space. Okay? Now, does that answer your question? Do you still have any questions after that? I mean, he answered all the questions. He just says it's everywhere, it's nowhere, and it's a concept that vibrates. Did you understand? So this is the problem. The problem is quantum mechanics has no answers. They're giving you the same answers that Mr. Tommy gave us 1,000 years ago for angels. Exactly the same ones, you know. And here is the issue, the next two issues, whether a particle can be in several places at once. Quantum calls it decoherence, and whether several particles can be at the same time at the same place. We have superposition, okay? And they intermingle these as well, okay? So what are they talking about? What is this superposition and decoherence? Well, fortunately, we have a little GIF that we can show you. And this is not from me, this is from them, okay? Just so you know. Here it is, okay? And they tell you this in your face, okay? Quantum physics, you know, we can have these two things. We can have a particle can be in two positions at the same time, and an atom can be excited and not excited at the same time. So we have yes or no, and maybe as well. So we've covered every base so that you don't ask any more questions, okay? We have answers for everything because, they make no sense. That's why. Okay, so keep in mind that the answers, the replies, the physical interpretations that quantum mechanics gives you are nonsense. They're just as much nonsense as Tommy's angels. So don't laugh at Tommy, okay? He was there, 1,000 years ago. He has an excuse. What's the excuse of all these bozos? Okay, that they claim that, particles are everywhere and they're vibrations of fields and whatever. Okay, and here's Tommy's tunneling, how a particle goes, in his case it was an angel, goes from one place to another. He goes from A to C without passing through B. That was the issue that St. Thomas Quantum tried to explain, okay? And here's today how we do the same thing in quantum mechanics, okay? And here it is, the answer. whether a particle passes through intermediate space. According to quantum, this is from a site, okay? According to quantum mechanics, the ball has a wave function, and this function is defined over all space. There is always a chance that as the ball encounters the hill, the ball will suddenly be found beyond it. A part of the wave packet representing an incident quantum particle can filter through the barrier boundary and eventually perish after traveling some distance outside the barrier. What these people have invented is a mechanism. You can call it a mechanism. You know, let me get this thing out of there. What these people have invented is a mechanism where they say, look, what you have is... This is the notion you have to keep in mind. They say a particle is only detected at emission and at detection, at reception. Okay, in between it travels as a wave. Okay, you got that? So the only way we can detect it is not as a wave, because the wave function collapses and turns into a particle. That's the notion you have to have in mind. So you have this particle, starts out as a particle, but immediately turns into a wave for who knows what reason. It's the wave that travels through the air, and that's, you know, you have James Maxwell saying, yeah, it's a transverse wave. Okay, he mathematically described it, okay, with his equations. And now what happens when it reaches the other end? The only way you can detect it is when it again condenses suddenly, for no reason whatsoever, into a particle. Okay, so suddenly the wave function collapses and turns into a particle. But what happens if you put a barrier? Well, they're saying that the wave, it doesn't delay. It appears on the other side instantly, as if the barrier wasn't there. So yeah, just like Mr. Tommy here, you know, Tommy Quantum, he said, you know, they say, quantum says, you know, particles appear on the other side instantaneously, like it didn't go through the intermediate space. Okay, so we have the same notion that good old Thomas Quantum had 1,000 years ago. Okay, and here's one more. If I can get this thing up there. And that's whether a movement of a particle is instantaneous, which is more or less the same thing with the intermediate space, because they're related. And we have this, again, entanglement and tunneling all in one, where, you know, a particle affects another one instantaneously, and a particle goes through a barrier instantaneously. So the notions are still there. You know, does a particle go through from A to C, and does it pass through B? That's one issue. And does a particle affect another one instantaneously? Okay, and the only thing that the quantum mathematician has to answer is the mechanism. You know, what is the mechanism for that to happen? Please explain the mechanism, and we'll understand. And right now they have no explanation for this. What they're doing is introducing ghosts and spirits in between. They're just doing it with magic. And they have no rational explanations. And of course, the rational individual out there, the layman, says, well, something's wrong here. Of course something is wrong. You won't understand quantum mechanics, you won't understand general relativity, because they're in the business of moving concepts, which is what Tommy did. You know, St. Thomas Aquinas, he did the same thing 1,000 years ago. He was talking about angels, spirits. And he justified them. And he said, you know, angel has all these superpowers because they were ordained by God. So what's changed? What's different in quantum mechanics? What's different in general relativity that is different from that? And you won't find any difference. As you can see, all those concepts that St. Thomas Aquinas had 1,000 years ago were either reinvented or applied to particles of quantum mechanics, every single one of them. And so whenever you hear something like that and it sounds irrational to you, it's because it is irrational, because they're moving concepts. Okay. Anyways, I'm going to finish up with Mr. St. Thomas Aquinas on, Wednesday. And we'll continue with geometry. We're trying to figure out what this, especially what the point is. We got this point particle, and somehow that point particle turned into a line, and the line is not a line. Line is distance. A line is motion, displacement. A line is time. It's everything except a line. And you wonder what all those things have to do with geometry. Okay, and this is where how we got into Aquinas, because Aquinas does an analysis of that primarily for the purposes of time. He's trying to figure out God, especially how God knows all of time or is outside of time, and so for him, all exists simultaneously, the block universe, so to speak. Another thing that we borrowed from him. And if we have this block universe, that means God, if he's omniscient, he knows already what you're going to do tomorrow. And if he knows that I'm going to move my right hand next or my left hand next, I hope I'm doing the right hands here. If God knows that, I had no free will. And this is what troubled them. This is the issue that they were trying to figure out, because God can't be omniscient and also allow you to have free will. And all these religious folks, they don't understand. They try to accommodate free will with omniscience. And this is where St. Thomas Aquinas got involved with geometry. And of course, he's going to introduce the point and a line, and just like Aristotle and Euclid did before him. Okay, so we're going to continue with these subjects on Wednesday. If you're interested in them, pop your head in here, and you'll hear a different version of science that you'll hear from mathematical physics. We'll see you then. Bye bye.